The James Webb Space Telescope, JWST, found a small asteroid that no one expected to find. The space rock is about the same size as the Colosseum in Rome. Since the space telescope was sent into space at the end of 2021, it may have found the smallest object ever seen in space. The James Webb Space Telescope has been making headlines in the field of astronomy because it's found huge objects in space that are sometimes billions of light years away. However, the recent discovery shows that the powerful instrument can be used in ways that no one expected much closer to Earth. Even more impressive is that the team that found the 330 to 660 foot, 100 to 200 meter asteroid did so by using data that was collected to calibrate the mid-infrared instrument MIRI, which was never meant to find new asteroids. An astronomer named Thomas Mueller from the Max Planck Institute for Extraterrestrial Physics said in a press release, "We found a small asteroid using MIRI calibration observations that are open to the public. This discovery came up completely out of the blue. The data are some of the first measurements that MIRI has made that are aimed at the ecliptic plane, and our work suggests that the instrument will soon find a large number of new objects." There are millions of space rocks in the main asteroid belt, which is between Mars and Jupiter. These rocks were made from leftover parts of the solar system from when it was made more than 4.5 billion years ago. There are dwarf planets like Ceres, which is about 620 miles, 1,000 kilometers across, and pieces that are less than 33 feet, 10 meters across. One of the biggest of these objects is Ceres. Asteroids can be thought of as fossilized leftovers from the beginning of the solar system, and studying them can tell us a lot about how planets like Earth were made. This is true for smaller asteroids, which have been looked at less in depth than their bigger main asteroid belt relatives because they're harder to track. Since this is the case, the fact that the JWST found a small asteroid is very encouraging. It means that in the future, astronomers will be able to use the telescope to study asteroids with a diameter of less than about a half mile. The JWST got the information while it was looking at the main belt asteroid 10920 1998 BC1, which was discovered in 1998. The team saw this collaboration as a failure, mostly because of how bright asteroid 10920 1998 BC1 was, and because the JWST was pointed in the wrong direction. After deciding that the data could be used to build and test a new way of figuring out an object's orbit and estimating its size, the team did an investigation that showed the photobombing asteroid. The researchers were able to figure out that the asteroid had a low inclination orbit, that it was in the inner part of the main asteroid belt, and that they could estimate its size. Mueller said, "Our results show that even failed Webb observations can be useful to science if you have the right attitude and a little bit of luck. Our results show that even Webb's observations that were thought to have failed can be useful to science." The researchers said, "Our discovery is in the main asteroid belt, but the JWST is so sensitive that it was able to see an object about 100 meters long from more than 100 million kilometers away." Astronomers will now learn more about the new object's orbit by comparing it to the orbits of background stars. This is a great result that shows how MIRI can find an asteroid in the main belt that was too small to be seen before, said Brian Holler, a JWST support scientist at the Space Telescope Science Institute in Baltimore. Plans are being made to repeat these observations, and we're fully expecting new asteroids to show up in those pictures. Let's talk about another topic now. So, the James Webb Space Telescope has a huge amount of strength. A picture of the galaxy that was just released by the European Space Agency shows us a part of the universe that other telescopes can't reach. Because the oldest galaxies in the universe are so far away from us, their light has stretched into wavelengths that we can't see. NASA says in their explanation of the spacecraft that Webb's speciality is to look at longer wavelengths of infrared light. When Webb looks at places in space that are so far from Earth that it's like the sensor is looking back in time billions of years, this picture shows how the galaxies looked when light stopped traveling through them a very long time ago. In the picture, you can also see that in the foreground, near the bottom of the picture, there's a beautiful spiral galaxy called LIDA 2046648. It's only about 1 billion light years away, which is much closer than the vast galaxies that lie past it. Our Milky Way is a spiral galaxy too. Everything else in the picture is a galaxy, except for the things with 6 points, which are stars that are much closer to us. When bright light sources pass through a telescope like Webb, they can cause something called diffraction spikes. The European Space Agency, ESA, gave an explanation that said, "This picture of the month from the NASA James Webb Space Telescope shows a dense field of galaxies. The image also shows bright stars that are topped with Webb's signature six-pointed diffraction space. In the distance, there are a lot of galaxies that look orange or red. Because the universe is getting bigger and the stars are moving farther apart, their light has become stretched. Webb's superb infrared vision helps the telescope look back in time, says the European Space Agency, ESA. This is because light from very far away galaxies gets redshifted toward infrared wavelengths. The European Space Agency, ESA, the Canadian Space Agency, and NASA worked together on research for the Webb telescope. When this picture was taken, astronomers were actually taking pictures of galaxies and stars to calibrate the telescope's sensitive sensors. The main goal of this research is to compare images of galaxies in the Milky Way with images of the first and earliest galaxies that have never been seen before. Astronomers want to know how galaxies like ours came to be and how they change over time. Most of these galaxies have hundreds of billions of stars and an incredible number of other planets. All of this adds up to an uncountable number of strange new worlds, some of which may be places we can't even imagine. Even though some say we can't, we can. Not even this, adding more to the discoveries of James Webb's telescope. It's taken pictures of Neptune in a whole new way. The NASA observatory that cost $10 billion got the best look at Saturn's rings in more than 30 years. Some of the planet's rings haven't been seen since NASA's Voyager 2 flew by in 1989. This was the first time a spacecraft had looked at Neptune. Infrared light was used for the first time in the pictures taken by the Webb team. These pictures show dust bands that are not as bright and narrow rings that are very bright. The near-infrared camera on Webb doesn't see Neptune in blue because it takes pictures in the near-infrared range of 0.6 to 5 microns. In fact, methane gas absorbs so much light that unless there are high-altitude clouds, the planet is completely dark at these near-infrared wavelengths. People can see these methane ice clouds as bright streaks and patches that reflect sunlight before the light is taken in by methane gas. Neptune, which orbits in a dark, faraway part of the outer solar system, is called an ice giant because of the chemicals that make up its interior. Small amounts of methane gas in Neptune's atmosphere make it look blue in visible light, but the near-infrared camera on Webb doesn't see it that way. A thin, bright band near the equator of the planet could also be a sign of global atmospheric circulation, which is what makes Neptune's winds and storms happen. Webb's pictures also show an interesting brightness at the North Pole and the first sign of high-latitude clouds surrounding a vortex at the South Pole. The telescope also took pictures of Neptune's 14 known moons, like Triton, the big, strange moon that looks like a bright point of light. Triton is covered with frozen, condensed nitrogen, which makes 70% of the light that hits it bounce off. Thanks for watching this video. Stay tuned for more.